All right, the next Lewis structure problem involves ammonium ion. We've got NH4 plus, and we got to figure out these other molecular properties. So count up the valence electrons. I've got 5 on nitrogen. I've got hydrogen bringing me 4 because I have 4 of them. And the positive charge contributes -1 valence electron because it's missing one of those electrons. So I get a total of 8 electrons. Now, we would still want to arrange our molecule or our species as symmetrically as possible. The nitrogen in the middle and the hydrogens all around. And then the next step would be to draw that single bond to all of the atoms from the central atom. I would reduce my electron count. 8 minus 8 is 0. So I've ran out of electrons. Everything has an octet. So go ahead and place this guy in brackets with a charge outside because it is an ion. All right, because it's an ion, I want to use those brackets, and I do have octets, so I'm done. All right, 4 electron groups. 4 electron groups, 4 geometry groups means tetrahedral geometry. With no lone pairs, my molecular geometry is also tetrahedral. And because of that geometry, my bond angles can be determined to be 109.5 degrees. Remember, with ions, polar or nonpolar is not really applicable. And again, the same way, the intermolecular forces would be only ion forces. Because of the geometry is the electron geometry is tetrahedral. I can predict that the hybridization is sp3. And with 4 bonds to hydrogen only, single bonds, I can predict 4 sigma bonds, and no double bonds, no triple bonds means no pi bonds. Okay, that's the ammonium ion.